Two things are sitting in your kitchen right now: a roll of aluminum foil and a salt shaker. Together, they produce the same sustained heat powering every single hand warmer sold on this planet. The same chemistry, the same duration, the same temperature for less than the cost of a cup of coffee. But in 1912, the year electric heating was born, something happened, and quietly, without a ban, without a debate. This knowledge was walked out of the room, not stolen, not destroyed, just forgotten. Or was it? Because the formula never disappeared. It has been sitting in plain sight in every chemistry textbook since the early 1900s. And today, Hidden Fix Lab is bringing it back. Welcome to Hidden Fix Lab, the channel that digs through 100 years of economic decisions to find what the industry quietly stopped teaching you. Now, before we go any further, if you have been with this channel for a while, you already know what we do here. But if you are new, hit that subscribe button right now. Think of it this way. You would not walk away from a neighbor who just told you your heating bill could be cut down using something already in your kitchen drawer. So do not walk away from this channel either. And one more thing before we begin. Drop a comment below and tell us where in the world you're watching from today. Whether you are in Canada dealing with -30 winters, or somewhere in Europe where the energy bills have quietly doubled in the last 2 years, this video was made for you. Now, let us go back to 1912 and find out exactly what was forgotten and why. Long before gas lines ran under city streets and electric meters clicked on the sides of houses, ordinary people already knew how to stay warm. They did not need a utility company. They did not need a monthly bill. They needed iron, salt, and the knowledge of what happens when those two things meet in the presence of moisture. That knowledge is older than most people realize. In Japan, during the late Edo period, running from the early 1600s through the mid-1800s, craftsmen and soldiers used early chemical warmers pressed against the body for both medical recovery and cold weather survival. These were not luxury items. They were practical tools built from materials anyone could find. In medieval Europe, blacksmiths noticed something that no textbook ever made famous. When iron filings were left in damp conditions overnight, the pile grew warm. Not hot enough to burn, warm enough to matter. They recorded it. They used it. And then, slowly, that observation was absorbed into the background noise of industrial progress and quietly left behind. The first formal American record of this principle appeared in 1891, when a New Jersey inventor named Jonathan Ellis filed a patent for a chemical hand and foot warmer. The device was documented. The reaction was described in precise technical language. The patent office recorded it. And then the world moved on, because 1 year later, something far more profitable arrived. In 1911, a man named Earl Richardson in Ontario, California, introduced the first electric heating pad sold to American consumers. He called it the El Warmo. That single product was not just an invention. It was the opening of a new economic model, one where warmth would no longer come from chemistry a person could replicate at home, but from a wire connected to a meter, connected to a monthly invoice. By 1912, the electric appliance industry was organizing. By the 1920s, it was lobbying for standardized household electrical infrastructure across the country. By the 1950s, furnaces, baseboard heaters, and HVAC systems had restructured the American home around one assumption. That warmth is something you purchase, not something you produce. The iron-salt reaction did not disappear from science. It disappeared from conversation. Universities still taught oxidation and exothermic reactions in first-year chemistry. The thermochemical measurements were published, peer-reviewed, and archived, but no one in a hardware store ever pointed to a box of steel wool and explained what it was actually capable of. That is just economics. When an industry is built around selling you heat, it has no financial interest in reminding you that heat can be made for free. The knowledge was not banned. It was simply never repeated loudly enough to compete with a television advertisement. The formula survived anyway, sitting in textbooks, sitting in patent archives, sitting in your kitchen drawer, waiting for someone to remember. Most people see rust as damage, a sign that something is breaking down, wearing out, losing value. But chemistry tells a different story entirely. Rust is not just decay. It is energy being released, and the amount of energy locked inside that process is enough to keep a person warm for half a day. When iron meets oxygen and water, it oxidizes. It forms iron oxide. That reaction does not just change the color of the metal, it releases heat. The chemical equation is straightforward. 4 iron atoms combine with 3 oxygen molecules to produce 2 molecules of iron oxide, releasing 824 kilojoules of energy per mole formed. That number is not a theory. It is a measured, documented, peer-reviewed fact sitting in thermochemical literature since the 19th century. A 2004 study published in the journal Corrosion Science confirmed that sodium chloride dramatically accelerates the oxidation rate of iron by disrupting the passive oxide layer that normally slows the reaction. In plain language, salt breaks down the natural barrier iron builds to protect itself. Once that barrier is gone, fresh iron is continuously exposed to oxygen. Electrons transfer faster. The reaction rate jumps by orders of magnitude. Weeks of slow rusting collapse into hours of usable, sustained heat. A second study from the Journal of the Electrochemical Society documented how activated charcoal extends and stabilizes this reaction by acting simultaneously as a moisture reservoir and a heat distributor. Without charcoal, the reaction runs unevenly. It spikes, fades, and delivers inconsistent warmth. With charcoal evenly distributed through the iron source, the heat output becomes steady, measurable, and reliable across a full 8 to 12-hour window. This is exactly the science inside every commercial hand warmer on the market today. Iron powder, sodium chloride, activated charcoal, and water. That is the complete ingredient list. The brands add vermiculite as a moisture regulator and seal everything inside a breathable pouch. But the chemistry underneath the branded packaging is identical to what a person can assemble in their own kitchen for under $1. The aluminum foil is where the efficiency equation changes completely. Polished aluminum reflects over 95% of infrared radiation. Wrapping their reaction inside a foil pouch with a small air opening does not just contain the heat, it recycles it. The same principle behind emergency space blankets and reflective roof insulation, applied to a handful of steel wool and salt. That is just economics. The science was never hidden. It was simply never handed to the person standing in the cold. The year was 1923. A Japanese inventor named Nichi Matoba received the first commercial patent for an iron-based body warmer. His device worked. The chemistry was sound, but the manufacturing cost was high because his version used platinum as a catalyst. It never reached mass production. And that single economic barrier bought the electric heating industry another 50 years of undisturbed growth. By the 1950s, the American gas and electric utility sector was generating billions in annual revenue built entirely on household dependency. The National Electrical Manufacturers Association, founded in 1926, had spent 3 decades lobbying for standardized grid infrastructure across every American city and suburb. Their argument was modernization. Their result was a population that no longer knew how to heat a room without a monthly invoice. The simplified iron, salt, and charcoal hand warmer that the public recognizes today was not mass commercialized until the 1970s. By that point, the outdoor recreation industry had grown large enough to create its own revenue stream. Companies like Grabber and Heat Factory did not invent new chemistry. They packaged ancient chemistry, applied trademark law to the branding, and placed the product next to $80 camping gear on retail shelves across the country. Once the formula was sealed inside proprietary packaging and surrounded by affiliate marketing, outdoor magazines, and sponsored survival guides, the public understanding of what was actually inside the pouch effectively vanished. Not through regulation, not through suppression orders, through market structure. That is just economics. No company funds the education that eliminates its own customer base. One voice tried to push back. Dr. Gordon Aiken, a materials chemist at the University of Sheffield, published findings in 1987 documenting the full replicability of commercial exothermic heat packs using consumer-grade iron sources and standard electrolyte solutions. His paper appeared in the Journal of Chemical Education. It was cited in academic circles. It was never mentioned in a single product brochure, outdoor industry publication, or mainstream consumer guide. Today, the global disposable hand warmer market is valued at over $1.5 billion and is projected to exceed $2.5 billion by 2033. Every dollar in that figure represents chemistry that costs under 50 cents to replicate. The raw materials are unpatentable. The reaction is undeniable. The markup exists for one reason only: because the person buying the packet was never told what was inside it. A retired school teacher in rural Minnesota named Carol Hendricks spent 4 winters paying over $2,000 a year in heating costs. She used commercial hand warmers daily from October through March, 40 packets a month, sometimes more. Then a neighbor showed her 3 ingredients she already owned. She has not bought a single commercial hand warmer since. Her material cost that first season was $31. The method begins at a hardware store or grocery. 1 box of medium-grade steel wool costs approximately $3 and contains enough iron source material for 20 to 30 individual heat packs. Medium grade matters. The coarsest grade runs too hot and burns through quickly. The finest grade restricts airflow and slows the reaction below useful temperatures. Medium grade delivers the correct surface area for a sustained 8 to 12-hour output. Pull a fist-sized portion of steel wool, roughly the size of a large egg when loosely held. Separate the strands gently so air pockets form throughout the material. Compression is the enemy of this reaction. Oxygen must reach the interior continuously, or the heat fades within the first 2 hours. Loose and open is the correct structure. Mix 1 teaspoon of table salt into 3 tablespoons of water and stir until fully dissolved. This is the electrolyte solution. Submerge the steel wool portion for 20 seconds, lift it out, and squeeze gently. The material should be damp, not dripping. Too wet causes uneven heat and risks salt water leakage. Too dry starves the reaction of the electrolyte it needs to accelerate. Add 1/4 teaspoon of activated charcoal powder, available at pet stores as aquarium filter media or at pharmacies in capsule form. Work it evenly through the damp steel wool using fingers. Even distribution is critical. Charcoal concentrated in one area creates a hot spot. Charcoal spread evenly produces steady, consistent warmth across the entire pack surface. Cut a 12 by 12 inch sheet of standard kitchen aluminum foil. Place the prepared mixture in the center. Fold the foil up around all sides, but leave one end open approximately 1 inch. That gap is the oxygen inlet. A completely sealed pouch exhausts available oxygen within minutes and stops generating heat entirely. Within 10 minutes, the pack will be noticeably warm. Within 20 minutes, it reaches full operating temperature between 35 and 50 degrees Celsius. Wrap the finished pack in a folded kitchen towel before placing it against skin or inside a pocket. The total material cost per pack sits between 40 and 65 cents. The commercial equivalent retails between $1.50 and $3. That is just economics. The formula was never lost. It was simply waiting in the kitchen drawer the whole time.